Hi, my name is Alice, and today I'll be sharing with you my solution to the supposedly impossible question from Edexcel Higher Paper 1 2022. There's been a lot of talk this week amongst my students, on social media, even in news headlines about how difficult this question was. People have been calling it impossible. It wasn't impossible, but it was very hard and very fiddly and involved a lot of different topics. So let's see how to solve this, and hopefully it helps you, and I'll give you some exam tips as we go along. Now, just a quick disclaimer, I did not steal this from Edexcel. I haven't seen the paper or the official mark scheme as I'm a maths tutor. And this question was told to me from memory by my students. I solved it myself, and then I just checked on social media that I got the same answer as other people had. And in this video, I'll be doing a full step-by-step tutorial of how to solve this, along with advice on how to do well in your exams. If you don't want all that, skip to the end. I have time-stamped the full solution at the end. So here we have 3 identical circles with a radius of 4 centimeters, and they're overlapping each other such that the center of each circle is on the circumference of the next one. And we need to find the area of the shaded part. Now, much like any other shaded area question, what we'll need to do is find the area of the bit that is not shaded and subtract it from the whole circle. Sounds easy, but this is just like the hardest shaded part question ever. So the way we'll be doing this is we will break down the part that isn't shaded into 4 identical segments and then subtract those from the circle area. And because it's non-calculator, we'll be doing a lot of fiddling around with algebra as we do that. So first of all, now this is something that however you got on with the rest of the problem, if you revised well for your maths exam, you could have probably done this step. So exam tip number 1, it's a circle, there's area involved. Let's write pi r squared. Always write a formula that you think might help. Now, we can see that the radius is 4. So let's do 4 squared to make 16, and writing the area in terms of pi, we get 16 pi for the area of the circle, which is the area of each circle, of course, because they are identical. Now then, here's where it gets a bit spicy. So we've got a segment here that we need to find the area of. The way to do that is we find the area of this sector, which is this slice of the circle here. Then we subtract from that the area of this triangle, and that leaves us with the segment area. But how? Well, first of all, we'll need to find the sector area. Now, this is the part, this particular step is the part where a lot of people told me they got stuck. And it's finding this angle at the center, because we need to know that so that we can do sector area is angle at the center, divide by 360 to make a fraction, times by the circle area. That's our sector area. But what is that angle? Well, here's how I figured it out. The angle is 120 degrees. And I knew that because, you know, when you're constructing a hexagon, you do that thing where you draw a circle and then you keep your compass the same distance as the radius, and you can draw these lines like this, and then you join it together to make a regular hexagon. That regular hexagon can be divided up into 6 equilateral triangles, each one of them having a 60-degree angle, of course, because they're equilateral, giving us 120 degrees for 2 of those, which is also a third of the total angle at the center, 360. Now, quick exam tip, if you don't know what that angle is, or you're not sure, just guess what you think it might be. You could probably even see from the picture that it looks like about a third of the circle. And as we will see as we go along, there is a step coming up which pretty much guarantees quite a small choice of angles that it could have been. So if you don't know, just guess. Don't just stop because you didn't know one small number. Right, here we go. We're going to put a few things together. So we have the area of our sector, which is 120 over 360 times by pi. We can simplify that, look, to a third. So then we've got 1/3 times by pi r squared, which gives us 16 pi from before, you may remember. And then we can simplify that to 16 pi over 3, or 16 over 3 pi. And there we have the area of the sector in terms of pi. Next of all, we need to have a look at this triangle here. Now, as you can see, I've split it up into two different triangles because that gives me a right angle triangle that I can perform some basic trigonometry on. I say basic, it's a bit less basic because we're doing non-calculator, so we'll need our exact trig values. So we've got our 60-degree angle here, as we saw before. We've also got the adjacent side, which is 2 centimeters. We know that because it's half of the radius of 4. And what we'll need to know to be able to find the dimensions of the triangle so we can find its area is this side here, which in terms of our trigonometry is our opposite side. So we've got the adjacent and the opposite, so we'll be using the tangent formula, and we'll have opposite equals tangent of the angle times by the adjacent. Now, here's where that knowing what the angle was thing that I mentioned comes in, because using our exact trig values, there's only quite a small number of answers it could have been. So we know that tan 60 is √3. So we'll do tan 60 times by our adjacent side, and that will give us, in the end, when we simplify it and put in our exact trig value, we'll get 2√3. Now, there aren't many angles that we learn for our exact trig values, and that is why there wasn't a very large choice of angles that could have been, as I mentioned earlier on. So that's the height of this triangle. We know the base now and the height of the triangle, so we can do half base times height, which will give us a base times height is 2 times 2√3. Half that, and we find we're back where we started actually, because we times it by 2 and divided by 2. So the area of half of the triangle is 2√3. So the area of the whole triangle is 4√3. And as I previously mentioned, to find the area of our segment, we subtract the triangle. So the segment area is 16 over 3 pi, take away 4√3. There it is. Now, this is a very key piece of the puzzle because, as we discussed earlier, we'll now be subtracting 4 of those from the circle area to find our answer. Okay, finally, we have got everything we need, and we just need to do a bit of fiddly algebra to put it all together and make a fairly elegant solution, I think. Let's see. So we have got our circle area, which was 16 pi. Feels like a long time ago, doesn't it? And from that, we will be subtracting the area of 4 segments. So let's just put that in. 16 pi take away 4. Now, the segment was 16 over 3 pi. take away 4 root 3. So we'll tidy all of this up now, and it does make quite a lovely simplified expression eventually. So let's just, I like to simplify in chunks, don't know about you, so I'm just going to do this bit. So this bit is 4 times 16 is 64, so we get 64 over 3 pi. And then you've got 4 times minus 4 root 3 is minus 16 root 3. So we're subtracting that from 16 pi. So let's just put that back in. There we go. Right, let's get rid of this bracket and put this all together. So next step, let's do 16 pi. We'll take, now be careful with the minuses with this bracket. This is where I would tend to make a mistake near the end. You're tired, we've done a lot, and this is a small thing, but watch out for it. So you've got 64 over 3 pi taken away because it was a minus. And then the middle one, the middle one here is going to change to a plus because it's take away minus changes to a plus. Maybe you weren't going to get that wrong, but I would have, I think. 16 root 3 again, of course. Right, now I'm just going to zoom in on this part here because we've got 2 terms containing pi. So we're able to simplify this part. So let's see what happens there. I'm just going to, just so I'm writing a bit less and making it easier for myself, I'm just going to do it with subtracting fractions and then pop my pi back in afterwards. So I'm going to do 16 over 1, take away 64 over 3. Then I'll make the denominators the same and do equivalent fractions. So we get multiply top and bottom by 3. We get 48 over 3. Take away 64 over 3. And 48 take away 64 is minus 16. So this part becomes minus 16 over 3 pi. Let's just put that in. So this whole part here, minus 16 over 3 pi. Hopefully you followed that bit. Right, and then we've still got this plus 16 root 3 here. Right, that's the answer. You could leave it like that, but I just want to tidy it up a bit. So let's just make it look nice as we've come this far. I'm going to swap them round so that we don't start with a minus. I just like it like that. So I've got 16 root 3, take away 16 over 3 pi. And let's just make it even neater. I'm not sure you would need to really do this to get the marks. I think you got the marks by the time you've done that previous step. But let's just do it to make it look really lovely at the end. So final completed answer, we'll just factorize it so that we end up with 16 times root 3 minus pi over 3. And that is finished. Wow. That was hard, wasn't it? But what a nice feeling to have that done. I haven't seen other people doing that last step where they factorize, but I just thought that was a nice bonus part at the end there. As I said, by the time you've got to this page and written out this whole expression, you've pretty much solved it at that point. But I think simplifying it would be best. I don't know if they said you had to simplify it in the question because I haven't seen the question. Anyway, we're done. So I'm going to now show you the full solution as a summary. and then we'll count how many topics we used and realize just why this was quite so difficult. So here we go. Right, in summary, we found the area of the shaded part by subtracting the areas of 4 equal segments from the circle area. So first of all, we did area of the circle, pi r squared. In terms of pi, that was 16 pi. We found the area of the sector, which we did by doing the angle in the center is 120 over 360 times by 16 pi the circle area, simplifying to 16 over 3 pi. To find the segment area, we then have to subtract the triangle, which I've highlighted in yellow, from the sector area. So we used some non-calculated trigonometry there, and we found out using our non-calculated trigonometry and exact trig values that was 2 root 3. We then found that the area of the triangle was 2 root 3 as well. And then we went on to double that, which gives us the area of that whole yellow part there, and subtract it from the sector to give us the area of one segment, which was 16 over 3 pi minus 4 root 3. Then we multiplied that by 4 and subtracted it from the circle area, and then simplified it. And I chucked in a bonus factorization at the end just to give us the most elegant and simple answer. So the simplified version was 16 root 3 minus 16 over 3 pi, or you could have put minus 16 over 3 pi plus 16 root 3 if you like. And then I just factorized it just to make it look really pretty at the end, and did 16 times root 3 minus pi over 3. Done. So that was a really hard question because you needed to know so many different things to answer that. Let's look at the topics we used. So maybe you counted different, but I noticed 12 topics here. There was the area of a circle in terms of pi. There was the area of a segment, which to find the area of this particular segment, we needed to find the area of a sector. We needed to know about constructions to realize the size of the angle at the center. We used angles in a triangle. We used triangle area. We went on to use right angle trigonometry, exact trig values, fraction arithmetic, surds, simplifying, factorizing. Oh my goodness. So that's why it was hard. But if you're a bit of a nerd like me, maybe it was a bit fun. Anyway, that's how to do that. And if you like what you see, then this is a brand new YouTube channel I've just started. So if you could like, share, subscribe, all that, that would be fantastic. And thank you so much for spending some time with me and doing some maths with me. And I hope I'll see you back here soon. I'm going to do a video every week. Bye.